to today's webinar. Thank you for attending and hope that it's beneficial today as we talk about some new exciting software that we have that is focusing on the green infrastructure, low impact development side of things to aid in design, analysis, comparison of multiple phases, pre versus post, its development conditions, water quality volume, runoff volumes. So we're excited today to show this, and excited that there has been a tremendous amount of interest in this as well. So we'll get started, and just so you know who's speaking or who's behind the scenes, Jess and myself will be presenting today. And again, this is part of our XP Live webinar series. Since there were so many that we felt like were possibly new to XP, we wanted to again talk about the company a little bit, our background in the engineering and technical services side for software. And I want to stress that the support team is worldwide, the US and the UK and Australia. We have all the time zones pretty much covered and are able to help whatever the situation is on the time zone. So the offices are in those locations as well as distributors worldwide. So not only from the XP Solutions standpoint of this product, but as well we continue to strive to improve and keep the products up to date. So we're looking for feedback and your input into making this a great product as we move forward with what we're going to talk about today, and that is XPDRAINAGE. XPDRAINAGE is a completely new product. It, of course, is backed with the many years of experience and ability with XP Solutions products. And so, just real quick, I'm going to click over to the software just to look at a model. I'll give it a minute. There is sometimes a delay between screens, so I'll try to be mindful of that. Just so you know what we're talking about today, this is XPDRAINAGE. It is a full geospatial working environment, so you can see you're able to bring in a variety of background data and or site-specific information relative to images, aerial imagery that is, for example, shown here, also GIS data that may be available, as well as CAD information. So this product straddles the fence a little bit in design and being able to bring in CAD, DWG, DXF information and use that in the model building process to help make things more efficient and not have to redo effort or work that has already been done perhaps in another aspect of design. So the user interface is pretty simple, as you can see. We have some plan view in the center, a toolbar, which is pretty common with latest Windows products at the top. On the left, we have what we call a tree view, or a place for us to manage phases and then all the elements of the low impact development, water quality, volume analysis. And on the right hand side, we have some toolboxes, just a quick, easy place to go grab some of the building blocks, the elements that go into setting up a model. For example, stormwater controls, and these drag and drop onto the working area in the middle called the plan view. Direct your attention over to the left side. We talked about the unique ability to do multiple phase comparisons. We'll demonstrate today and call your attention to the left side here a few times because we're excited about this and the ability to have multiple phases. Now, what we've shown in our examples is pre versus post because that's very common. There could be multiple phases, one with a certain set of stormwater controls, one without any stormwater controls, maybe simulating pre-development, maybe multiple phases of the actual development, for example, a residential subdivision or something like that, or commercial development that's going to happen in phases could literally be put in phases. And then the output can be looked at, and we'll show you this as we go, and looking at the results to toggle on and off whatever phases you want to compare to get a water quality comparison of pre versus post and water quantity comparison of pre versus post. One last thing, and we'll flip back to our PowerPoint here, but just want to highlight the fact that these tools along the top, the tabs are set up to mimic a workflow. So you'll hear us several times here in the next hour mention the workflow, and these tabs are intended to help mimic that series of steps. So we start with our site information, details, drainage areas, the actual ground surface, things like that. We have to have some rain, typically. That's kind of our reason here, is looking at water on the ground, and we'll have a number of ways to look at and put in rainfall. And then pollutants, it's pretty straightforward, all the pollutant data that we want to include for an analysis. Then we have some things that we call design tools, and these are pretty exciting, just simple calculators that help with storage volume estimates, water quality volume estimates, a first flush volume estimator. So, and then we get into the building. So when we're actually putting the details, for example, of a very complex developed site that is made up of multiple stormwater controls, ponds and swales, permeable paving, all of the different various stormwater controls that may be characteristic of a site in a proposed development can be shown, and all of those are accessible from the Build tab. And then of course there's some analysis that takes place, and then of course we can look at results and then get results out of that. So just quickly, and I think that was less than 5 minutes, an overview of the software and kind of what you can expect as we talk about this for the next few minutes. So again, if you're just joining, thank you very much for joining, and we're going to look at a few things in our PowerPoint now, just as I mentioned, kind of what we're going to go through, talking about this product to aid in the analysis for many kinds of comparisons of phases. We say pre versus post, but it can be multiple phases of comparison of flows. So we're talking about quality as well as water quantity as well as water quality. So we can put in pollutants, and many of the stormwater controls have an efficiency of removal, a percent of removal, and details that are put in, and we'll talk about that. And the workflow, we mentioned that just a moment ago looking at the program. We want to be able to calculate stormwater runoff and pollutant washoff to estimate volumes that we need to then control or mitigate either the quantity and the volume or the quality, which is so very important today in many areas. We want to be able to then compare that, do comparisons. If a series of stormwater controls that are strung together, perhaps a green roof drains to a grass swale, drains to a bioretention swale, then before it leaves the site, is that enough to treat water quality? And we have the ability to put multiple scenarios together and do comparisons for what makes the most sense economically, and maintenance, life cycle costs, all the factors that we may juggle in trying to make the decision for an appropriately designed low-impact development site or green infrastructure. Locating them on the site is also key. And then, as we mentioned, a lot of times it's modified. Reruns, comparing results, trying to hone it to not just meet regulatory requirements. Of course, that's important, obviously, but then other factors that may be in as well. And at the end, we need to get results out. We need to submit to an authority or a reviewer. We need to demonstrate in a quantifiable way that this treatment train is effective in flow and pollution control. So we'll touch on that today, and then we'll go through just a handful of slides, hopefully not PowerPoint anyone to death here, but then we'll flip back over to the software, look at a couple of examples, and hopefully it'll spawn questions, some interest that you may have, and you may see where this could help you in your work, or perhaps be an effective tool for use for low impact development, green infrastructure design and analysis. In the past, we've had a certain bent, if you will. My background has been stormwater manager for a municipality as well as consulting engineer, and I understand both sides of the struggle. The interest, though, that I think we all have at heart is to preserve natural aspects and water quality and the goals of clean water. And somehow we have this renewable resource. It rains and we collect it and we store it. And that is a value. We're seeing that more and more today. It's a value to us. How can we utilize and capture that value on site? And these terminologies that we use, green infrastructure or low impact development, things like that, are just kind of describing our effort to make sure that what the built environment around us somehow doesn't make worse or somehow destroy the environment. So we are pushing stormwater to the front. We are trying to consider, and this is going on worldwide, looking at the need for this and valuing that resource. It's been proven in various studies that a well-designed site that elevates water quality and quantity has all of these other benefits. It tends to be valued, and it brings it out front. It unburies it. It daylights it, and people have appreciated that. And of course, it's significant change to the past paradigm. So we welcome it, and we're excited about it to be able to in a demonstrable, quantifiable way do this mitigation and or effectively treat our pollutants on site, recharging groundwater, evapotranspiration to help with urban heating, its attractiveness and appeal in our urban spaces being more green and preferably a little less gray. So that is an approach that many are taking voluntarily and or from a regulatory standpoint, and so we see this product being suiting that need, and we hope it does as well. And so we try to take into account natural flows. We try to look at what effect our development will have on stormwater quality and quantity, and then what do we do with that? We have a variety of stormwater controls available to us, and a whole libraries of them, and the ASCE's Manual of Practice, the latest one, is describing those in detail and designs. But how do we distribute that across the site? How do we look at it that it's affordable and robust and maintainable? It certainly is complicated and can be difficult to then quantify and put into a set of plans, a given document that many engineers are required to seal and takes on a life of its own. So we need help with that, and that's where XPDRAINAGE comes in. Our aim with XPDRAINAGE is to provide that tool to help be able in a quantifiable, demonstrable way account for natural flows on the site, look at comparisons, be able to look at volumes and water quality, and are those goals, are the desired goals achievable on our sites, and if so, how and can we demonstrate that? And we really think this treatment train approach that distributed across the site is a great way to describe that, because we find more and more in the real world these do end up being strung together or distributed across the site. Water flows across multiple types of stormwater controls, And so we have the hope, the aim with XPDRAINAGE, that you'll see that benefit from that. We've created templates in the software so you don't have to do and redo things like rainfall setups and methodologies, and things that can be saved to make your work faster and more efficient has also been included in XPDRAINAGE as well. So again, we had talked about, and I'd mentioned the idea of the workflow. That is what's being shown in this slide. That is very well put together, thanks to Jess. This workflow looks at calculating pre-development. So if we have some baseline condition, we're looking at runoff quantity, and then we look at quality, the pollutants, what comes off the site, and existing conditions. And then we have some estimation. What kind of volumes do we need to control the flow? What is our water quality volume, for example? What are the estimates of a first flush analysis that might give us a hint or an indication, a beginning point to look at designing stormwater controls? Then we connect those together. We go into the build phase of the model, of the tabs that we show at the top, and we look at the stormwater treatment and the various processes that we may have strung together. Maybe it's a green roof that flows to a permeable parking lot, that goes to a green swale, that flows to a wet pond, that then eventually discharges from the site. And or at some point in the game, they may change and decide we're not going to have the green roof. The building footprint changes, for example. Then we have to modify, and we go back and we recompare. And so this was the thinking when XPDRAINAGE was conceived and set up, so this workflow helps you move through what we hope mimics kind of the real world. And again, we solicit your feedback as you use the product, and we can help improve it and continuously improve it as well. Before we go to the actual program and look at 2 or 3 models and do some demonstration, I want to call your attention to a couple of things that we think are pretty handy tools to have in, and hope you will as well. One is we call a deluge, so it's not really trying not to scare anybody into thinking that all of a sudden they're a modeler. We're not trying to say that, but this is just quickly, if we dumped water on the surface, where would it go? One of the goals or aims in elevating stormwater to the front of the development design process in our urban design is, well, where is the water? Can we answer that question? Many times on a site, they can't, because we in XPDRAINAGE can bring in the terrain, the surface of the lay of the land. We built in, there's a handy tool to just dump water on it. You can determine how much, and it spreads that water out. Where does it go? Where does it accumulate? Where are the lows? Where are natural areas that may be great, suitable for detention? Maybe if the slope is too much, maybe it's not suitable for certain types of stormwater controls. But the deluge helps look at those flow paths and give you any phase. You can use the deluge. If the CAD folks are redoing the proposed grading and give you the grading plan, then you can deluge that and have a look at it. And that's tremendously important as the development process iterates, as we know it does. So I want to highlight that. One other thing, we've already touched on this, but the phases. It's not limited to pre and post. We could have, phase 1 through 10 here that could represent a number of things. It might be phases of the development, certain blocks that develop or types of development. It could be variations and combinations of stormwater controls. And so that's significant. In the past, it was difficult or cumbersome to have different phases and variations of your analysis and then compare those results. Could be quite cumbersome. We hope we've met that need and look at not only comparing the phases, but then of course you want to go look at the results, and that's easily done with a tick of a box. So one other thing I want to mention is in the software we've tried to make it user-friendly, to allow it to flow according to your workflow. And part of that is being able to quickly discern and translate the words. Which side slope are we referring to? What's the void ratio, and how's the software referring to that in this instance? So we've had some fantastic drawings done that are sketches intended to help make that almost a thoughtless effort. You can glance at an image, glance at a picture, and see exactly, what do I do here? And this will hopefully be a benefit to you. These are, I'll show you, you're able to turn these on or off, but they can be very helpful. The other thing we try to do is to gather up a lot of stormwater controls. And as you know, as involvement in this, there are a lot of stormwater controls, and we don't have them all probably. Certainly some of the manufactured units we don't have in. So for that we put in a user-defined stormwater control, trying to get that catch-all, but a lot of them we've tried to get so that they could be just inserted, and then the dialogue for data input with that stormwater control is just specific to that stormwater control, not a bunch of extraneous data that we don't really need. So the stormwater controls are the strength of it. All right, again, as questions are being answered here, we'll go right into the looking at a few models. Again, talking about the ability to set up the site. The first step many times in this analysis is being able to bring in the site. Looking at the software, that along the top the tabs roll across as a workflow. So initially all the site data can be brought in. This includes the surface, so that is critical for having the elements of a stormwater control can be read from how they are drawn in. So for example, we begin by putting in the drainage areas, and so each drainage area, wait just a moment for screen to refresh, so each drainage area can be brought in from CAD and is actually the actual area. Now you can overwrite that area or you can leave it, and so it's consistent with the areas in the other CAD files or GIS files. And then various things can be put in about pollutant concentrations and the pollutants you want to model, as well as characteristics of the area itself. And areas can be brought in along with the stormwater controls. So we have surface data, we have our images, we have CAD files, just showing you the areas, and the pollutants can be put in. And this is a couple of examples. Again, I'll wait for your screen to refresh. There is, in this location, a bioretention. And so that area can be drawn in, and you can leave the program to discern that area because you're in a geospatial work environment, it's keeping up with your XY coordinates. You can see in the bottom left, or potentially make out, it may be too small on your screen, but you can see an XY coordinate as well as an elevation. So say if we just went to this drainage area that drains to this bioretention, and then we were able to bring in the detailed information on that bioretention. Again, we won't go through every tab, I promise you, but you can see all of the pertinent information about the bioretention can be shown in this dialog. So you're not getting things that are extraneous to that pertain perhaps to permeable paving, but you're just focusing on the bioretention. I mentioned the images. Here in the bottom left of the dialog, you can click and it will bring up that image that shows. So It correlates to our filtration layers and our various aspects of this bioretention can then be recognizable exceedance level, for example, referring to that point beyond which the water leaves that stormwater control. And then other images are available there. For example, we have some photos that are included with. But these drawings are really intended to make the heads-up input of the particulars, the stormwater control details, somewhat easier. And then each layer can get into more advanced information about that stormwater control, each tab, excuse me, associated with that. So each of those are built in, and as we mentioned, the treatment trains. So we have one site draining to the next site, draining to the next site, and each of those, of course, are important and, interestingly enough, connected. So we kind of refer to the train, or the idea of them being strung together. This is a great example here, the permeable paving. So we have a portion of an area running across permeable paving, picked up in a curb inlet, it's carried over to another part of the system. And so they string together in the system. And the abilities, the flexibility in the program includes, of course, we've talked about the pre versus post development and having these controls that can be driven from a number of areas. So literally the user can drag elements onto the screen from the toolbox. We're able to right-click on elements on the left in the tree view and add those and load that information. Including all of the imagery, the GIS files, the CAD data, etc. So we have, I'll progress just along this workflow at the top so you can get a feel for it, the ability to go in and create SCS rainfall. And I have that in an example, a long-term rainfall, some observed event that the user wants to put in, and then we choose some rainfall that goes along with this simulation. So we would select some rainfall. We can also turn on the first flush analysis for that analysis. So the pollutants are simple. We can add pollutants here. Each pollutant concentration can be associated with that area, maybe the particular land use type you have, and can be saved in templates, of course, so that they do not have to be continually re-input as you build your model. So the next thing we want to point out is some of the design tools. We talked about this a little bit. We showed you the pre-development, so I'm going to change my phase here to my pre-development phase just simply by a pull down and a click. And I'll zoom out a little bit so you can see this was that same area. This was a pre-developed image, and so we have pretty much the same boundary that we've taken and clipped for a drainage area, but you see there's no development. There's nothing, it all drains, and so it's just one area, and we have the ability to deluge this area. And we have already done that, so we don't take up time now, but it's very quick, just takes a second to run. But I just want to highlight here kind of what you see. So you get the ability to control what you see, depths and contours and arrows and things, and how that's shown. There's a legend that can be turned on or off via the left-hand tree view. But you get an idea early on in the process of where the water's flowing on our site, pre-development. Okay, there's a few other design tools I want to point out while we're here. We're still looking at our pre-developed site, just getting an idea of water quality, quantity, volumes, etc. I can go to my volume estimator, pull up the volume estimator, and I have the ability to look at storage estimates. So if I leave this box ticked, it reads that drainage area from the geoplan. I could untick that and put in another area if I wanted, but I have ability to put in a runoff coefficient and then some discharge rate. What's the allowable discharge rate? And then I can quickly tell what the estimate would be. And as soon as the screen refreshes, there you go, that's the estimate. So it gives you a quick estimate of what kind of storage volume you would need to retain this desired discharge rate. Also click over and notice a water quality tab here. And this is exciting because this is that water quality volume that you may be looking for. So we assume some depth of rainfall, again a C factor in some area. We can adjust the percent of that volume portion of it, and then we get a resulting runoff volume as well. So that is a quick calculation. Let me pop up another model here just to demonstrate that. And so if we look at this example, I'll wait for your screens to refresh there. This shows a few drainage areas going to a site where they're planning a new building. So there's some existing drainage areas to the upper right-hand corner, but then one of the drainage areas here is actually proposed for a new building. And so with that site, we're looking at all of these drainage areas and what would be the water quality volume. So we put in, say, an inch of rain. It's all industrial, so we're going to assume a fairly high C factor. Put in the area portion of it, hit calculate. It gives us about 25,000 cubic feet for our water quality volume. So that's these are, again, just a quick estimate of what's needed. If we look at the first flush, very similar. Again, these are some things you can do at any phase. It doesn't have to be the pre-developed phase. I was just demonstrating that. It could be any of the phases you have set up for the design, but it's going to look at and want some area and then a runoff C factor, and then the first flush gives you a total calculation there for the pollutants. So those are set up, easy to get to design tools just with bringing data in and getting some simple areas down that you're able to look right at that. So we will switch back over to the model that we had talked about here with the deluge. This is looking at just that pre-development development phase, but we go ahead and do the development, and we have a plan. We see what they're going to do, what other things are we doing, and then we get into actually drawing in our stormwater controls. So we drag over our bioretention and we give it an area, and we start tracing some pavement for permeable pavement. Maybe we have the roadside swale here where one of the areas is connected to a green swale, and that conveys water. Ultimately, all of this ends up in a treatment pond at the very end. We're going to call it a wetlands, a wet pond at the very end. So all of these can be, as illustrated here, strung together in a connection to be able to help design and size appropriately the stormwater controls. So looking at a few other of these aspects that I want to be sure and pointing out, we talked about the stormwater controls and what's built into the software, plus the user-defined to sort of catch all. We've talked about some of the volume calculators to help sizing. The analysis is the next thing to look at. So there's a set of analysis criteria, and that analysis criteria lets you specify, of course, the rainfall that is specific to this, as well as a first flush run, and that is selected once. There's also a validation tool. This just does a quick check to make sure that the model's ready to run. The proper connections have been made, rainfall is selected, pollutants are populated, all those sorts of things. And it gives you a quick check. And then we hit go, and just that quickly, actually the screen takes longer to refresh than the simulation did, so pops up there. This is just a quick view. I'll show you more in just a second. The results. So you see kind of levels, depths, flows, inflows, outflows, volumes, percentages. The status on the far right is just a highlight to say that it went past that exceedance level. And of course we put some things in this model so that it would trigger that, to be able to point that out. More results are available though on the results tab, including a full design report. So this creates a full exportable letter size document of all of the stormwater controls and elements. And then there's individual ways to look at phases, if we just want to look at phases, if we want to look at just an individual item, and maybe one is all that's subject to change. Maybe it's the bare lots and we're just not sure how much that will change. Or maybe we are not sure if we are going to be able to do the permeable paving, and we have to look and see how beneficial that was. So those are changed. I want to click on one though here just to illustrate. This is the design report phases that allows you to tick these boxes here and show that you're on or off of a given set of results. So right now everything is shown, and we'll update this, and a quite extensive bit of information can be shown here. Of course, if we had multiple phases, all of those phases would show up. Here we're just comparing pre versus post. So bear with me, I'll resize and move some things around here so that it shows on the little web viewer screen. Okay, so you can see that you have the ability to show rainfall perhaps, and if I untick one of these, it disappears from the graph, and I can print or save these out anywhere along the way. So inflow and outflow is important. I want to highlight also at the top it has the phase name, and we're looking at pollutants in this case, and it shows the reduction, what's pre, what's post, and have we met those. So we can quickly compare, you know, we've met our 80% reduction, or excuse me, 20% reduction or 25% reduction goal, if that's our goal. And then we can turn off various aspects of the result analysis, re-update that report, and it changes what we're looking at. So, and then of course those can be saved and exported too, as you right click on the graphs especially, and the tabular data can all be exported as well. And that is probably one of the more exciting elements that we have on the results side, to be able to show the performance of flow and volume from all of the stormwater controls. I do want to stress the templates. Again, the templates are the time saver and efficiency. We set up our rainfall. If we're always working in a particular region or council or area, it makes it easy to set up those templates and save. If we're looking at total suspended solids and any number of other pollutants that we want to create, we could add more pollutants here. Just keep adding pollutants, and then for whatever land use you have and whatever on that particular inflow or drainage area, then you associate that with that particular area. So one one area. We've just put in 3 here. Obviously you could have many more, and all of those would be included as well. Let's see, it looks like we have a few minutes, so I do want to show that we have a lot of time of concentration methods built in. So if you're not sure of your time of concentration, we can have those calculated, put in areas, and then input the information, and that helps speed up the process of calculating time of concentration. Those are calculators as well, and associated with those drainage areas and inflows. Okay, I'm going to switch back now to the PowerPoint. I want to call your attention to our online help. And this is just a screenshot, but just so you know this is for real, we're going to actually bring this over. So if you click on help in the software somewhere, you actually pull up and get this help. All of those graphics and images and that information, the dialogues, all of those are reflected in the help file. This is online, so it's constantly being updated and refined to help with new elements that are added, as well as questions that you might have. On the left there is an analysis, so looking at an interest in templates, we can click on this and go right to a description of the templates and see where it's accessed from, what's to be done with it, saving them, and again, that's where you pick up your efficiency with working, and it's very helpful. So that's a beneficial aspect. But that's not all. You're not left with just online help. We have our stellar worldwide support system. So as I mentioned, we have our support team in the US, and very knowledgeable and accessible through all of the day. We have a support team in the UK. So what that means for you, a user, is basically if you're on the East Coast and you get up really early in the morning and work, then the UK's can pick up support as the day goes, then our US operation picks up support. So we have it covered throughout the day, and actually into Australia, so you have all time zones covered. But for us in this webinar, I just want you to know that with the purchase of the software and keeping up your subscription, it means that you can get the support, not just the online help, but our tech support and access to them to help you with all your questions or needs. That's the bulk of wanted to present. The software is available. There are some trial basis availability to it. It's also available to purchase. The best way to reach that information is to the email address here at the bottom of the screen, aemsales@xpsolutions.com. With that, I want to thank you again for attending today's webinar, and please contact us if you're interested in trial use of the software, if you're interested in ready to purchase, and we can answer any other questions you might have and or comments. Again, please feel free to contact us. Here's our email address, our phone number, and of course the website.